The Pliocene Epoch is the period in the geologic timescale that extends from 5.333 million to 2.58 million years BP. It is the second and youngest epoch of the Neogene Period in the Cenozoic Era. The Pliocene follows the Miocene Epoch and is followed by the Pleistocene Epoch. Prior to the 2009 revision of the geologic timescale, which placed the four most recent major glaciations entirely within the Pleistocene, the Pliocene also included the Gelasian stage, which lasted from 2.588 to 1.806 million years ago, and is now included in the Pleistocene. As with other older geologic periods, the geological strata that define the start and end are well identified, but the exact dates of the start and end of the epoch are slightly uncertain. The boundaries defining the Pliocene are not set at an easily identified worldwide event but rather at regional boundaries between the warmer Miocene and the relatively cooler Pliocene. The upper boundary was set at the start of the Pleistocene glaciations. Etymology: the Pliocene was named by Sir Charles Lyell. The name comes from the Greek words I euro I micro a I 1/2 and I plus or minus I to the first I 1/2 I and means roughly continuation of the recent, referring to the essentially modern marine mollusk faunas. H. W. Fowler called the term a regrettable barbarism, and an indication that even a good classical scholar such as Lyell should have requested a philologist's help when coining words. Subdivisions: in the official timescale of the ICS, the Pliocene is subdivided into two stages. From youngest to oldest they are Psenzian, Zaneklene. The Psenzian is sometimes referred to as the late Pliocene, whereas the Zaneklene is referred to as the early Pliocene. In the system of North American land mammal ages include Hempylian and Blancan. The Blancan extends forward into the Pleistocene. South American land mammal ages include Monchomoscan, Trapadmalalan and Arquayan. In the Paratethys area the Pliocene contains the Dacian and Romanian stages. As usual in stratigraphy, there are many other regional and local subdivisions in use. In Britain the Pliocene is divided into the following stages: Gedgeravian, Waltonian, Pre-Luthamian, Luthamian, Thernian, Bramatonian or Antian, Pre-Plastonian or Baventian, Pastonian and Beastonian. In the Netherlands the Pliocene is divided into these stages: Brunsumian C, Reuverian A, Reuverian B, Reuverian C, Protiglian, Tiglian A, Tiglian B, Tiglian C1-4B, Tiglian C4C, Tiglian C5, Tiglian C6 and Eburonian. The exact correlations between these local stages and the ICS stages is still a matter of detail. Climate: the global average temperature in the mid-Pliocene was 2 degrees Celsius higher than today. Global sea level 25 m higher, and the northern hemisphere ice sheet was ephemeral before the onset of extensive glaciation over Greenland that occurred in the late Pliocene around 3 Ma. The formation of an Arctic ice cap is signaled by an abrupt shift in oxygen isotope ratios and ice-rafted cobbles in the North Atlantic and North Pacific Ocean beds. Mid-latitude glaciation was probably underway before the end of the epoch. The global cooling that occurred during the Pliocene may have spurred on the disappearance of forests and the spread of grasslands and savannas. Paleogeography: continents continued to drift, moving from positions possibly as far as 250 kilometers from their present locations to positions only 70 kilometers from their current locations. South America became linked to North America through the Isthmus of Panama during the Pliocene, making possible the Great American Interchange and bringing a nearly complete end to South America's distinctive large marsupial predator and native ungulate faunas. The formation of the isthmus had major consequences on global temperatures, since warm equatorial ocean currents were cut off and an Atlantic cooling cycle began, with cold Arctic and Antarctic waters dropping temperatures in the now isolated Atlantic Ocean. Africa's collision with Europe formed the Mediterranean Sea, cutting off the remnants of the Tethys Ocean. The border between the Miocene and the Pliocene is also the time of the Messinian salinity crisis. Sea level changes exposed the land bridge between Alaska and Asia. Pliocene marine rocks are well exposed in the Mediterranean, India, and China. Elsewhere, they are exposed largely near shores. Flora: the change to a cooler, dry, Seasonal climate had considerable impacts on Pliocene vegetation, reducing tropical species worldwide. Deciduous forests proliferated, coniferous forests and tundra covered much of the north, and grasslands spread on all continents. Tropical forests were limited to a tight band around the equator, and in addition to dry savannas, deserts appeared in Asia and Africa. Fauna, both marine and continental faunas were essentially modern, although continental faunas were a bit more primitive than today. The first recognizable hominins, the Australopithecines, appeared in the Pliocene. The landmass collisions meant great migration and mixing of previously isolated species, such as in the Great American Interchange. Herbivores got bigger, as did specialized predators. Mammals in North America, rodents, large mastodons and gomphotheres, and opossums continued successfully, while hoofed animals declined, with camel, deer and horse all seeing populations recede. Rhinos, three-toed horses, oreodonts, protoceratids, and chalicoteres went extinct. Borophagine dogs and Agriotherium went extinct, but other carnivores including the weasel family diversified, and dogs and fast-running hunting bears did well. Ground sloths, huge glyptodonts, and armadillos came north with the formation of the Isthmus of Panama. In Eurasia rodents did well, while primate distribution declined. Elephants, gomphotheres and stegodonts were successful in Asia, and araxes migrated north from Africa. Horse diversity declined, while tapirs and rhinos did fairly well. Cows and antelopes were successful, and some camel species crossed into Asia from North America. Hyenas and early saber-toothed cats appeared, joining other predators including dogs, bears and weasels. Africa was dominated by hoofed animals, and primates continued their evolution, with Australopithecines appearing in the late Pliocene. Rodents were successful, and elephant populations increased. Cows and antelopes continued diversification and overtaking pigs in numbers of species. Early giraffes appeared, and camels migrated via Asia from North America. Horses and modern rhinos came onto the scene. Bears, dogs and weasels joined cats, hyenas and civets as the African predators, forcing hyenas to adapt as specialized scavengers. South America was invaded by North American species for the first time since the Cretaceous, with North American rodents and primates mixing with southern forms. Litopterns and the notoungulates, South American natives, were mostly wiped out, except for the macrauchinids and tuxodonts, which managed to survive. Small weasel-like carnivorous mustelids, coatis and short-faced bears migrated from the north. Grazing glyptodonts, browsing giant ground sloths and smaller caviomorph rodents, pampotheres, and armadillos did the opposite, migrating to the north and thriving there. The marsupials remained the dominant Australian mammals, with herbivore forms including wombats and kangaroos, and the huge diprotodon. Carnivorous marsupials continued hunting in the Pliocene, including dasyurids, the dog-like thylacine and cat-like Philocolio. The first rodents arrived in Australia. The modern platypus, a monotrim, appeared. Birds. The predatory South American Phoras haesids were rare in this time. Among the last was Titones, a large Phoras haesid that migrated to North America and rivaled mammals as top predator. Other birds probably evolved at this time, some modern, some now extinct. Reptiles and amphibians. Alligators and crocodiles died out in Europe as the climate cooled. Venomous snake genera continued to increase as more rodents and birds evolved. Rattlesnakes first appeared in the Pliocene. The modern species Alligator mississippiensis, having evolved in the Miocene, continued into the Pliocene, except with a more northern range. Specimens have been found in very late Miocene deposits of Tennessee. Giant tortoises still thrived in North America, with genera like Hesperotus tudo. Madtsoid snakes were still present in Australia. The amphibian order Aleaudata went extinct. Oceans continued to be relatively warm during the Pliocene, though they continued cooling. The Arctic ice cap formed, drying the climate and increasing cool shallow currents in the North Atlantic. deep cold currents flowed from the Antarctic. The formation of the Isthmus of Panama about 3.5 million years ago cut off the final remnant of what was once essentially a circumequatorial current that had existed since the Cretaceous and the early Cenozoic. This may have contributed to further cooling of the oceans worldwide. The Pliocene seas were alive with sea cows, seals and sea lions. Supernovae. In 2002, Narciso Benitez al. calculated that roughly 2 million years ago, around the end of the Pliocene Epoch, a group of bright OB stars called the Scorpio Centaurus OB Association passed within 130 light-years of Earth, and that one or more supernova explosions gave rise to a feature known as the local bubble. Such a close explosion could have damaged the Earth's ozone layer and caused the extinction of some ocean life. See also, List of fossil sites. References. Further reading, Cummins, Neil F. William J. Kaufman III. Discovering the Universe. New York, New York, Susan Finnemore Brennan. ISBN 0-7167-7584-0. Gradstein, F.M. Ogg, J.G. and Smith, A.G. 2004, A Geologic Timescale 2004, Cambridge University Press. Ogg, Jim. Overview of Global Boundary Stratotype Sections and Points. Retrieved April 30, 2006. Van Andel, Tiered H. New Views on an Old Planet, A History of Global Change. Cambridge, Cambridge University Press. ISBN 0-521-44243-5. External links, Mid-Pliocene Global Warming, NASA GISS Climate Modeling, Pliocene, PBS Change, Deep Time, Pliocene, Possible Pliocene Supernova, Supernova Dealt Deaths on Earth? Stellar blasts may have killed ancient marine life. Science News Online retrieved February 2, 2002, UCMP Berkeley Pliocene Epoch page, Pliocene microfossils, 100+ images of Pliocene foraminifera.